Hello everyone, welcome to Science Tutorial. And today on Science Tutorial we're going to consider physics as a subject. In the episode we usually tag Physics Meal. But this is a special series. Why is it a special series? We are looking at revision series for WASI and UTME candidates. That's students preparing for West African Senior School Certificate Examination and those preparing for the tertiary institution examination. That's the one being organized by JAM. That's the Unified Tertiary Matriculation Examination. So it's going to be a special series, special revision series for all the candidates that are preparing for this exam, even those that are also preparing for NECO exam. So today we want to start from the basis. So it's important that you follow this series before your exam. Definitely you will enjoy it. So we are starting from the basis, which is the concept of measurement. The concept of measurement. So since it's a revision series, we will not take much time. We need to raise some important points that the students need to know as far as the concept of measurement is concerned. So it will be very important if you stay away from every form of distraction, then get your writing materials ready and other necessary materials that you need for effective and efficient study. Now, if you have a past question, you also make it available, because at the end of the day, one of the things that will help you is after each topic, you go to the past question, search for those topics and answer questions on those topics. So let's begin. Now, measurement is very, very important in science. Very important. The concept of measurement is an important aspect of sciences, because when we fail to measure some certain things, there will be problem. Even at home, we do measurements. Someone can ask you, get me some quantity of water, and maybe if it's water you want to boil for bathing, it will be different from the water you want to use to maybe make tea. So if it is water for bathing, you cannot use maybe a cup, only one cup of water for bathing. That would be terrible. Or maybe if it's water that you want to use to make tea, prepare tea for in the morning for breakfast, you will not use 50 liters gallon to get such water. So from time to time we carry out measurement. Even the tailor, when you take a cloth material, a material to the tailor will also take your measurement. So measurement is very, very important in life, and in sciences we don't joke with measurement. So there are three things that are necessary whenever we talk about measurement. So we say there are three important terms we usually consider in measurement. There are three important terms that we usually consider in the concept of measurement. What are these terms? These terms are quantity, dimension, and unit. So anytime we are dealing with measurement, we come across these particular terms. We always come across our quantity, we also come across dimension, and definitely we'll come across unit. So we're going to take time to look at each of them. Remember, it's a revision series, and we have to be very concise because it's a revision series. We'll hit the points that are necessary. So whenever we are looking at measurement, we must look at the concept of quantity, the concept of dimension, and the concept of what? Unit. So let's look at quantity. What exactly is a quantity? Quantity. A quantity is a physical variable that can be measured. So any physical variable that is measurable is what? A quantity. Any parameter that can be measured is a quantity. So anything you can measure is a quantity. It's a quantity. So our interest, that's why we say physical variable. Our interest, we center on those quantities or those variables in sciences. They are the ones that we are going to consider. So we have seen that anything that you can measure, any physical variable, any physical parameter that can be measured, we refer to it as what? As a quantity. As a quantity. Now quantities are bound, but in terms of measurement, there are two types of quantities that we usually look at as far as measurement is concerned. So there are two types of quantities we usually consider in measurement. There are two types of quantities that we usually consider in measurement. What are these quantities? What are these quantities? Namely, fundamental quantities. Fundamental quantities and derived quantities. So as far as measurement is concerned, we look at fundamental quantities and derived quantities. Now, like I said, we have other quantities like scalar quantities, vector quantities. But whenever we are looking at measurement, we look at these two group of quantities. That's fundamental quantities and what? And derived quantities. Very important, very important. So you see, we are trying to expand this now. We started by telling you that a quantity is any measurable physical variable, any physical variable that can be measured. And then now we said, as far as measurement is concerned, we usually consider two important quantities, and they are fundamental quantities and what? Derived quantities. So quickly, we have to say this: fundamental quantities. Fundamental quantities are quantities that do not depend on other quantities for their dimension. So those quantities that do not depend on other quantities for their dimension, we refer to them as fundamental quantities. They don't depend on other quantities for their dimension. So any quantity that will not be dependent on another quantity in order to obtain its dimension, that quantity is said to be what? A fundamental quantity. Now, there are seven common fundamental quantities. So we say there are seven common fundamental quantities. We have what we call the mass, we have the length, we have time, we have absolute temperature, we have electric current, we have amount of substance, and what we call luminous. Okay, let's write it here. Luminous intensity. 7 of them. So we have mass of a body is a fundamental quantity. Length is a fundamental quantity. Time is fundamental. Temperature, electric current, amount of substance, and what we call luminous intensity. It's also a fundamental quantity. It's also a fundamental quantity. So 7 fundamental quantities. 1, 2, 3, 4, 5, 6, and the word 7. Then on the other hand, derived quantities are quantities that depend on 2 or more quantities for their dimension. So any quantity that depends on another word quantity for its dimension, that quantity is what? A derived quantity. So a derived quantity. There are so many of them. So apart from these 7 fundamental quantities, we can actually say examples of derived quantities. Examples. So we can say examples of derived quantities. Let's write some of them. We'll talk about area of a shape. Volume is also derived. Density, you know about that. Speed is common. We have velocity, also that. Acceleration is derived. Force, impulse, momentum, energy, work, power, pressure, etc. There are so many of them, so we can go on and on. So all these are derived quantities. They are all derived quantities because they depend on other quantities for their dimension. So quickly, at least we now know what a quantity is. We now know what fundamental quantities are, and we now know what derived quantities are with example. Now we have to quickly look at the concept of dimension. Let's look at dimension. Quickly, we have to look at dimension, okay? So the second important term that we usually look at in measurement is what we call dimension. Just say one thing about dimension before we now move to unit. Dimension is used to show relationship between the fundamental and derived quantities. We're going to see how we do that. So dimension, we use dimension to show relationship between fundamental quantities and what? Derived quantities. Now quickly, I believe you have taken note of this. So quickly, let's define units. Before we now look at the units and dimension of fundamental quantities. So if I have 3 now, units. Units are used to distinguish 2 or more quantities. If we want to show the difference between 2 or more quantities, we use units. This one, we use it to relate fundamental quantities and the what? And derived quantities. Then we use units to show the difference that exists between 2 or more quantities. Let's explain this further. Supposing I just write 50, I write 50, I write 50, I write 50. Or maybe I entered the classroom and I started shouting 50. The students will be surprised, and I say 50. They say, "Sir, Master, what are you talking about?" I say 50. They say 50 what? I say just 50. 50. Some of them may think that maybe I'm insane. Some of them may run away from the class. you know. So what is odd for someone to start shouting 50? Say, what do you say this person say 50, 50, 50, 50, 50? It's just 50, 50. 50 what? So if I say 50, 50, 50, 50, no difference. But if I now put X here, standing for seconds, and I put this M standing for meter, and I put kg here, standing for kilogram, and maybe I put N here, standing for Newton. Now all these are units. By inserting these units, I can actually distinguish these 50s. So when I look at this one, by seeing this S, which is seconds, now somebody will know, oh, this 50, we are talking about what? Time. So this 50 is different from this, because this one deals with time, while this deals with distance, 50 meters. This one is talking about what? Mass. So that particular symbol that will be inserted to a numerical quantity in order to show the difference between that numerical quantity and another numerical quantity, that particular symbol is what we call what? Units. So we use units to distinguish two or more what? Or more quantities. So by looking at this, before we just wrote 50, 50, 50, we don't know the difference between them. But by looking at this now, the units have actually shown us what each 50 stands for. All right. So quickly, we're going to put up a table. We're going to look at the dimension and the units of fundamental quantities. Now, it's important that we note the units of fundamental quantities are referred to as fundamental units, while the units of derived quantities are called derived units. So, units of fundamental quantities are known as fundamental units, while derived units are units of derived quantities. So quickly, we're going to look at the dimension and units of fundamental quantities in a tabular form. So let's look at that. Let's look at that quickly before we begin to summarize the first part of this. So dimension and units of fundamental quantities. Okay, let's say we have a fundamental quantity. Okay, let's say we have that. We have the dimension. We have the units. And a small space. Okay, let's say units and their symbols. So the symbols of the units. Okay, quickly, let's look at this. Mass is one of the fundamental quantities. Mass is one of them. 2. Length is one of them. Okay. 3. Time is one of them. Okay. The other one, we mentioned temperature is one of them. Remember, we said electric current is one of them. 6 and 7, I think I still have space. Amount of substance. And finally, Okay, now what's the dimension of mass is capital M, dimension of length is capital L, dimension of time is capital T, time, capital T, dimension of temperature, we'll use theta or small t, electric current is I, that's the dimension, amount of substance is N, and luminous intensity, we use this Greek symbol for that, and use, call it phi, that luminous intensity. That's the symbol I drew there, luminous intensity. That's the symbol. So let's draw it in such a way that it will be clear. Okay. Now, what's the unit? The unit of mass based on SI unit is kilogram, and the symbol is what? kg. What's the unit of length in terms of SI unit is meter, and the symbol is small m. What's the unit of time? SI unit seconds, and the symbol is Hertz. Our temperature, we have Kelvin, and the symbol is K. We have ampere, and the symbol is capital A. We have mole, and we usually write MOL as the symbol. Then this one we have candela, and the symbol is CD. Wow. So these are the fundamental quantities. Their dimension, you're supposed to know this dimension, especially that of mass, length, and the word time, and also temperature, even electric current. You're supposed to know all of them, and the units. The units are based on SI units. Remember, mass can be measured also in gram, milligram, tons. Length, which is distance, can be measured also in meter, in centimeter, decimeter, kilometer, and so on and so forth. Time, you know, time can be measured in minutes, in hours, in days, in years, and so on. Electric current, ampere, moles, then we have candela. Now you must know this. These are the SI units of these 7 fundamental quantities. All right, so far so good. I believe that you are enjoying this revision. So we're going to go on a break, but I want you to do something quickly. Just go through your past question quickly, glance through your past question. If you have a past question that maybe from the year 2000 to 2020, then it's important that you just go through the past question. Look for questions that concerns fundamental quantities and derived quantities, especially those questions used to appear in the objective. So just go through those questions and see, maybe in some question they will just say which of the following is a fundamental quantity, or which of the following is the unit of a fundamental quantity. Now see, after watching this video, just go back and see if you can quickly answer the question within this short break, because we want to go on a break. And when we return, we are going to look at how we can actually obtain the units and the dimensions of derived quantities. We wish you all the best as you prepare for your external exam. Remember, exam malpractice is a crime, so make sure that you stay away from it. Proper preparation will always prevent a poor performance. So make sure you prepare very well for your exam, and then you see yourself excelling in exam. Thank you, and God bless you.